Good morning, students. Today we are going to read another very important topic in chemistry, that is condensation. So concentrate yourself. We are going to start. Condensation is the process whereby a gas changes into a liquid. This change in state takes place when a gas is cooled to its boiling point. Heat is evolved during the condensation process. Condensation takes place at a fixed temperature numerically equal to its boiling point. Figure shows the cooling curve for changing a gas into a liquid at constant pressure. From the graph, T2 degrees C is the condensation temperature of the liquid. So here is T2 degrees C. This is the condensation temperature. The gas starts to condense at temperature T2 degrees C. That is, gas starts to change into a liquid. The temperature remains constant from the time T5 to T6 because heat is liberated by the attraction between the particles which draw them closer together. So during this time, this is the process which is talking about. Both liquid and gas exist in equilibrium during the condensation process. And this is the time T6 at which the gas has changed completely into a liquid. Here is a question. The diagram represents a closed vessel containing equal volumes of the water and steam at 100 degrees C and atmospheric pressure. Question is, which of the following statement is true? A part is, equal number of the molecules is present in the steam and in the water. B part is, the only type of the movement possible for molecules in the water is vibration. C part is, some of the molecules in the steam split into hydrogen and oxygen molecules. And D part is, molecules can move from the water into the steam and from the steam into the water. So, look at the question again. Question is, the diagram represents a closed vessel. So, this is a closed vessel containing equal volumes of the water and steam at 100 degrees C and atmospheric pressure. So, D part will be the answer. Water continues to vaporize into the gaseous state at 100 degrees C. Also at this temperature, steam condenses back to form water. This will eventually come to a state of the equilibrium. So equilibrium state will be reached. Next topic is freezing. Freezing is the process whereby a liquid changes into a solid. Heat is evolved during freezing. Freezing takes place at a fixed temperature called the freezing point. Freezing and melting points have the same numerical value. A pure substance has a fixed freezing point. Impurities lowers the freezing point of a substance. Increasing pressure depresses the freezing point of water but increases the freezing points of other substances. So this is important point. All points are very important, but this is more important. The cooling curve for changing a liquid into a solid at constant pressure is shown in figure below. So here is a figure. T1 degree C is the freezing point of a liquid. Here is the T1 degree C temperature, which is the freezing point of a liquid. The liquid starts to freeze at temperature T1 degree C. The liquid state changes into a solid state. Temperature remains constant from time T7 to T8. So this is the time T7 to T8 because heat is liberated as strong attractions are formed between particles to hold them together in a crystal lattice. Both liquid and solid exist in equilibrium during the freezing process. And at time T8, this is the time T8, all of the liquid have changed into a solid. Next topic which we are going to read in the lecture is sublimation. Sublimation is the process whereby interconversion between the solid state and gaseous state occurs without passing through the liquid state. Heat is absorbed when a solid changes into a gas. Heat is evolved when a gas changes into a solid. Sublimation takes place at a fixed temperature. Iodine, tri-ice, aluminium chloride, and ammonium chloride undergo sublimation. So these are some examples. Normally in paper, you people are required to write down some substances which undergo sublimation. So these are the examples. Here is an figure shown. Sulfur gas has sublimed to a solid as it cools after leaving the volcano. Here is an exam tip. One reason why solid carbon dioxide, that is called dry ice, is used to keep ice cream cool is that dry ice sublimes directly into gaseous state and hence does not melt to produce a messy liquid. This is very important question. Next topic is dissolving. There are small gaps between the particles in a liquid. When substance dissolved in a liquid, its particles spread out and fills the gap. Figure below shows how particles in a solid are pulled apart by the particles in the liquid called the solvent and move between the particles of the liquid. So this is the figure. Solvent particles are going to fill between the gaps of the solvent. When a substance dissolves in a liquid, it forms a solution. Here is a question that is very important. A 50 centimeter cube sample of the alcohol is mixed with 50 centimeter cube of water. So 50 centimeter cube of alcohol is going to mix with 50 centimeter cube of water. Now the question is, the volume of the mixed alcohol and water is found to be 97 centimeter cube instead of 100, because in common sense, when 50 centimeter cube of alcohol is going to be mixed with 50 centimeter cube of water, common sense is the solution must be of 100 centimeter cube, but instead we get a solution of 97 centimeter cube. Which of the following is the best explanation? So B is the best explanation. The alcohol molecules fit into the gaps between the water molecules. Explanation is here. The water molecules in a liquid state will have gaps or spaces between them that allow for other particles small enough to occupy spaces between them. Alcohol is small enough to fit between the water molecules. So this is the reason the solution is of 97 centimeter cube. And here is a summary of changes in states of the matter. When solid melts, we get a liquid. When liquid boils, we get gas. Gas sublimes to solid. Solid sublimes to gas. When gas condenses, we get liquid. When liquid freezes, we get solid. Very important diagram. Okay, the next topic in the lecture is determining the physical state of a substance. The physical state of a substance depends on its melting and boiling points. Figure below shows how the physical state of a substance is related to its melting and boiling point. So this is the melting point. Below this, a substance will be solid. Above melting point, the solid will be converted into liquid. And at melting point, solid plus liquid state will exist. At boiling point, liquid plus gas state will occur. But above the boiling point, liquid will be converted into gas. Here is another question. Bromine has a melting point of -2 degrees C and boiling point of 59 degrees C. What is the physical state of the bromine at room temperature? So, definitely at room temperature, liquid state will occur because melting point is -2 degree, boiling point is 59 degrees C. So, liquid because the room temperature is lower than the boiling point of bromine and higher than its melting point. B part is, at what temperature will freely moving bromine molecules be in contact with bromine molecules arranged in a regular lattice? So, -2 degrees C at the melting point of the bromine, solid and liquid exist together in equilibrium. C part is, at what temperature will bromine have a fixed volume but not fixed shape? So at temperature greater than -2 degrees C but lower than 59 degrees C, bromine is a liquid. And liquid is a state that is having fixed volume but no fixed shape, as it takes the shape of the container. So this was the topic. Read it again, make your notes. Thank you so much.